Welcome to lesson 49, box plots and measures of spread. There's a lot to get through on this lesson. I'm going to go through the content and then I'm going to keep the examples separate because there is a lot to unpack here. And the first thing we're going to do is we're going to talk about what box plots are, and then later on we're going to come back to how we're going to draw them. We're going to interpret them. We're also going to look at some standard deviation things, some range, and so some concepts you may or may not have come across before. So basically I've written some definitions down for each one of them. A box and whisker plot is also called a box plot, depending on which textbook you're going to read. It shows the 5-number summary. Now, last lesson, we spent some time finding out what the median is. Now, the median, remember, was the middle number. We're now expanding that and saying, okay, we now need to find, so basically that's how we split the numbers in half. If you think about it that way, then the actual data is now in half, okay? We're also going to split that half in half again. So we're basically working out how much 25% is all the way along, okay? And then representing that in a data. So you can see here, and each one of these areas in here, so this part in here between the minimum and the lower quartile, and we'll get into those later on in a second on how to find them, but that's basically 25% there. So I could say right in there is 25% of the data. 25% of the scores, if we were talking about the scores in the upcoming math test, it would be 25% of the scores would be between the minimum and that lower quartile, which we call quartile 1, okay? And then in the next bit would be 25% in there, 25% in there, and 25% in there, okay? So that's the fundamentals of what a box and whisker plot is, okay? Range is another one we talk about, measures of spread. So we're looking at the difference between the highest and the lowest set of data points, okay? Which you should have come across before. The interquartile range is a new one. It's the difference between Q3 and Q1. And if we go back up here to the box and whisker plot, we're talking about the difference between these two values here. It's that middle 50% of the data. So the difference between the Q3 take away Q1 is going to get me my interquartile range. The next thing we're going to touch on is outliers. We did touch on them last lesson, but now we're going to actually define whether they are an outlier. So we spoke about the outliers being numbers that are way off. We have the spread of data here, and we have a random number that's way up there. Most people are getting 50 or 60% for their test, and then we get some people that are getting 90, or maybe one person that's getting 90 up there. So if it was 4 or 5 people, it wouldn't be an outlier necessarily, but we'd have to calculate that using this little system that we've got here. But generally speaking, it might only be one number, maybe 2 numbers that might be an outlier way up, and there might also be a score that's way down there at 4 or 5. Okay, so how we're going to calculate that is we need to know what the interquartile range, that middle number, the middle 50%, that Q3 minus Q1. And then we're going to use that interquartile range and we're going to raise it by 50%. So we're going to do the interquartile range, that range of numbers, but multiply that by 1.5. So here we're going to multiply the interquartile range by 1.5. And to work out the lower limit, we're going to take it away from Q1. To work out the upper limit, I'm going to add it to Q3. And that creates another little limit that sits out there in space. And I'm saying any numbers that are bigger than that are going to be outliers, and any numbers smaller than that on that way are going to be outliers, okay? So we'll touch on that with some examples. If you need some more questions when they come up in math space, make sure you reach out and ask for help. The next thing we're going to look at is standard deviation. Now, I'm not going to go into what the fundamentals are. We're going to use our calculator for doing this. There are some questions that in math space, and if you look at the actual lesson, it sort of tells you how to calculate it by hand. In reality, no one ever does that, okay? Whether you go into business, and standard deviation is absolutely used in business. So if you're going to be, and as is any of these data that we're looking at, statistics is very much useful. So if you're going to move into business courses that you think you want to do at university, this is information that you need. And you'll always have access to a calculator, and you will always use the statistics function on that calculator to calculate the standard deviation. And in essence, standard deviation is how far is on average, how far is that data away from the mean? So we'll calculate the distance between the mean each time, we square it, then we take the square root of that and divide it by however many terms there are. That's effectively what it is. I'd like you to go and research that and find that out for yourself. But for now, the main thing I want you to understand is if the standard deviation is higher, that means it's more spread out. Okay, the more spread out the data is, the higher the standard deviation. The more clumped together it is, the lower the standard deviation is going to be. Okay, that's the fundamental thing that I need you to take away from this part of this lesson. Okay, so I'll say it again. If the standard deviation is high, then the data would be more spread out. Okay, and the best way to use that is to compare two different. Maybe I can use the test scores in section 1, compare that to test scores in section 3, and knowing the standard deviation, that's going to help me determine whether it's more spread out or not. Okay. So now we're going to work out how to create a box plot. So I've got some steps down there. I've got 3 different steps that we need to do. The first thing we need to do is we need to find an appropriate scale. Okay, that includes all of our data. If we got test scores going from 0 to 50, that's what our scale needs to be. Maybe it's 1 centimeter equals 2 scores or 10 scores, whatever it is. Fit it nice, a nice 3/4 of the width of the page is a good way to do it, and then sort of divide it up evenly. There's no right or wrong, but sometimes if you've got a box and whisker plot that looks this big and you've got a piece of paper that's this big, it's probably not going to look very good. So you probably should stretch that out a little bit, okay? So choose an appropriate scale and then go from there. If we've got the test was out of 100 and we've only got scores that go from 25 to, 50, then we just go a little bit bigger than that, and that's as far as we need to go with our scale, okay? So just keep that in mind as well. So our next point is create a box using the lower quartile, the upper quartile, and the median as well, okay? So we've got those 3 different ones in here to create that box, okay? The line in the middle of that box is going to be my median. The 2 ends of the box are going to be my Q3 and my Q1, okay? So that's really important. And how do we find those? Remember, we put them in order, we find the middle value, then we find the middle value of what's left, okay? And I'm going to do some examples of that later on, okay? So once I've done that, then I need to draw the whiskers, which are these little bits up here. So these are my whiskers going all the way to the lower extreme and the upper extreme, okay? So, and then we just terminate at my high rate. And if we think about it now, what is this value, the difference between here and here? That's what my range is. So that's my range, okay? No, it doesn't need a dot, whoops. That is the range of data from there to there, okay? So that's an important thing that we need to know. And in here is my interquartile range, which is in there as well, okay? And the last little thing I need you to realize is that each section of that box, and I spoke about this at the start, each section of that box is 25%. So I know that this part's 25, this part's 25, this part's 25, and this part is 25. 25% of the data, okay? Now that's assuming even if we have got rid of our outliers, they are no longer part of our data, okay? But for now, we just want you to calculate if data exists, and then maybe in the coming years, we'll calculate the data. Then we'll get rid of any outliers, and then we'll calculate it again, okay?